Consider this a glimpse into your future. Inside robotics maker Apptronic's Austin lab, engineers are perfecting the next generation of workers. Built like humans, fueled by artificial intelligence. Yahoo Finance was invited in for an exclusive look.
Today we've got thousands of robots that do one thing. The future is one robot that can do thousands of different things.
Need input.
Input. All right, you got it.
The idea of a general-purpose humanoid has long been the stuff of science fiction. But generative AI is finally making that reality, backed by vast amounts of data and high-powered chips.
If this thing started walking towards me in a warehouse, that's a little intimidating.
That new technology is leading to new possibilities with chip leader NVIDIA right at the center of it.
The soul of NVIDIA.
There's no reason why every home should not have at least one humanoid or more.
The competition is growing, with companies like Elon Musk's Tesla vying to win a market projected to reach $38 billion, according to Goldman Sachs. That could have significant implications for the labor force. This is what's next in humanoid robots.
So go ahead and open up that right hand, pressing down on the joystick. All right. Now, when you reach for those socks, try to overshoot where you think you should be. Go just a little bit further. All right, go ahead and close that hand now. Very nice. Lift up. All right.
Oh.
Go ahead and drop it in that box. Fantastic.
I'm getting a crash course in machine learning, taking control of Apollo the robot through a VR headset and a pair of controllers.
Am I giving it too much force?
No, that was perfect.
Oh, so close.
It's a process known as teleoperation. In this case, I'm training Apollo how to pack a box and clear the table. The way I move its hands, the way I touch an object is all being processed as data to create a mental model for Apollo.
Historically, in the past, we've had to train engineers for years to speak the same language that computers speak, which is, programming languages and assembly language at some level. With teleoperation, anyone can go and pick up this rig, jump inside of it, and in 5 minutes, be training the robot, teaching the robot what to do.
That advancement led to a recent breakthrough for Apollo. In this video exclusive to Yahoo Finance, Apptronik says it shows the robot performing these tasks autonomously without a human operator, a result made possible based on just 10 hours of training.
The holy grail for us is what we call zero-shot learning, or the ability to show the robot what to do, and it can do it the same way that you do that task. And if we build big data sets of humans doing tasks in these environments, and we have robots with the same morphology as a person, then that allows us to have robots that can do a whole wide range of tasks over time.
Apptronik spent nearly a decade perfecting Apollo. It's built like a human, so it can work alongside humans. It's 5'8", weighs 160 pounds. It can lift 55 pounds with 2 arms and 2 legs.
We want the smallest robot that we can build that still is the most versatile robot we can build. So we were trying to find this trade-off.
Generative AI has supercharged that development by enabling humanoids to process more data more quickly. That means engineers no longer need to program every move. Robots can simply watch and learn.
This is all in one Apollo. So you can see there's a GPU, there's a CPU, and then this is sort of like the brain stem, and this is the nervous system that controls all of the motors. Robots in the age of AI have many more sensors, and so you have to read off of those sensors and then control that network of motors very quickly.
That's especially important when it comes to Apollo's hands in something called dexterous manipulation. It's second nature to us humans, but one of the hardest movements for robots to learn. 1 year ago, Cardenas says this wasn't an option. Now these fingers can grab objects and sense them with a vast network of sensors built into the hand.
There's all sorts of tasks that we do today with our hands where we're just, we're listening until it clicks. We're tightening until we feel it stop, and we can get it just right. So we have that high sense of touch. And that's very difficult to get robots to do, to replicate with the same level that people can do these tasks.
Investments are flowing in. Backing from big tech companies like Amazon and Microsoft set new records for funding this year, according to CB Insights. And it's about to get even bigger, with humanoid robots taking their first steps into the real world. Tesla's already touted its own humanoid Optimus working autonomously in factory floors. Figure AI's trained its humanoid for use at a BMW plant, while Amazon's integrated Oregon-based Agility's Digit robot into a test facility.
I would say we're at step 0.5. You kind of have this initial moment of breakthrough. People saw what was happening with large language models, and it's really taking that and applying it to the physical world.
NVIDIA's accelerated those applications by building an ecosystem for humanoids to run on. It combines high-powered chips that process data at high speeds with something called the Omniverse, a type of metaverse that allows users to train robots in the digital world for skills applied in the real world.
When you create a digital twin, you're able to simulate all of this in the digital world and then put it in the physical world and vice versa. So doing it in simulation is absolutely mandatory because it's faster, safer, and cheaper. In simulation, I could put 1,000 or 1,000,000 humanoids and I can test a different version of the algorithm in parallel. So just compute.
So fast, DiPutala says NVIDIA's doubling its computing capabilities every 6 months. Now the company's developing foundation models to speed up the pace of learning, so robots can copy any human movement just by observing.
Can you give me a high five?
Sure thing. Let's high five.
Can you give us some cool moves?
Sure. Check this out.
We are basically able to train the robot using text input, or it can take speech input, or it can take live demonstration or videos from the internet.
Tala says that technologies fundamentally change the use case for humanoids. It's no longer about robots that can perfect one task, but general-purpose robots that can do multiple tasks and learn to do even more.
My prediction is next year we'll have over 1,000, maybe a few thousand Optimus robots working at Tesla.
Elon Musk is racing ahead with his own plans. At Tesla's Fremont factory, Musk says 2 Optimus robots have already been deployed. He predicts there will be 1 billion humanoids working 2 decades from now.
Autonomous transport is called sort of a $5 to $7 trillion market cap situation. Optimus, I think, is a literally $25 trillion market cap situation. So.
Other companies, they need to go out and win contracts to demonstrate the capability, whereas Tesla, at least so far in what we've seen in the video, is just using it in their own factory. And so they don't need any sales force or anything like that to continue to drive performance and test things out. They have a factory, which is the perfect sandbox for them to keep pushing the limit.
The tech advancement comes as the U.S. faces a labor crunch, especially in manufacturing. Goldman Sachs estimates the industry is already short 500,000 jobs. That's expected to grow to 2 million by the end of the decade.
If you have a robot that can really do anything a human can, then that fundamentally changes the economy as we know it, right? Because then there's no more constraint on human labor.
What does the cost need to come down to in order for this to be able to be used on a much larger scale?
Yeah, so this goes back to that adoption curve where I think capability has to match the price point. And I think at roughly $100,000, if it could do 30% of what a human does, then that starts to be an interesting dynamic.
NVIDIA's DiPutala puts that price tag even lower, saying it needs to be $10,000 to become ubiquitous.
You sort of mentioned this rethink that's happening about a robot that can do one task versus a robot that can do 1,000 different things. Why do we need that?
So we don't have enough people to do the tasks and jobs that we need to be done, all across the globe. So if you look at the U.S., if every unemployed person got a job tomorrow, we'd still be short millions of jobs. So there's this dream of a versatile robot that can come in and fill the gap. and do a lot of these jobs that we're increasingly seeing younger generations don't want to do. Think loading and unloading trucks in the hot Texas sun, for example. It's very difficult to get people to do that today. And so this is, the initial types of applications where you can see a robot like Apollo step in.
Apollo's preparing to tackle its first job, with Apptronik deploying the humanoid inside logistics provider GXO's warehouses. It's also working with Mercedes-Benz to integrate the robots into the carmaker's manufacturing line. There are still questions about safety, physical safety with robots working alongside humans, but also cybersecurity and the potential for hacking.
We need to have that safety at the hardware level, at the chip level, in terms of functionally or security-wise. If anything is not quite right, you shut down or you gracefully stop. It needs to be designed at the software layer. It probably also needs to be defined at the layer in the cloud, where it is not just within the robot, but you have ability to connect to it and stop it, as needed.
Are we there right now?
I think it's going to be an evolution.
When you think about where this could all go, does that ever scare you? Does it excite you? Do you sort of think, should we create a limit to this?
For me, it excites me far more than scares me at all, in the sense that, in the end, we have multiple checkpoints that we can have. First of all, policy could come in place. And all the companies that we're trying to create, it's mostly trying to solve for all good scenarios, right?
For me, the dream of a versatile robot is things like elder care, where you have a whole series of things that you need a robot to do to be able to take care of us as we get older. You need basically a nurse, and you need a housekeeper, you need a variety of different things that you need this robot to do. And so just one narrow piece of that robots can do today won't solve the problem. And so for us to really realize the dream of robots, where we have these helpers that really free us up and enable us to do new things, we need much more versatility than we have today.
So that sounds like in the future, every house has an Apollo, right?
Yeah.
Is that what you envision?
Yeah, I think in the future, every house will have a robot. The question is what form it will take. I think it will be some sort of humanoid, depending on how you define that. And yeah, I think that similar to the personal computer or to smartphones today, I think that it'll be hard to envision our lives without robots in the future.